Half angle identities. All right, in the last video, we talked about double angle identities. We said that those were the types of identities you would use if you were to have, I don't know, information. I can just like zoom in, can't I? If you were to have information about like, let's say an angle X here, but like you really wanted to know about, for whatever reason, twice that angle, let's say you knew the sine values of this guy here, but you wanted to know the sine values of 2x that we could do. We had formulas that would allow us to do that. Now it's the same idea when we go to talk about half angle formulas. The only difference here is like, let's say you had an angle like this that you knew about. So you knew about the bigger angle, but what you wanted to know about was a smaller angle, x over 2. So you wanted to know about half the angle, the sine and cosine values there. Um, that's what these half angle identities are. Um, these ones are a little more tricky. You'll see from these formulas that we have plus or minuses in them, which means a choice needs to happen. So the fact that it has these plus or minuses is really important. It's really, really important that you see the plus or minus, that you understand that it's there, and that a choice needs to be made. The other thing I'm going to mention here, similar to the double angle identities, this is not really a half angle identity. This is just a quotient identity that I've listed here because it's useful. Not really a half angle identity. Now, as you can see with these, they kind of like there's one minus cosine of x or one plus cosine of x over 2. For these guys here, it's like the same formula. One's a minus, one's a plus. The thing is, cosine of x is typically going to be a fraction, which means you're going to be doing a lot of like simplifying of fractions here, of complex fractions. That's when you have a fraction within a fraction. So I want to talk about what that simplification looks like so that you have an easier time of it when you come down to actually simplifying these, that you don't have to grab a calculator to simplify. Okay. All right. I'm might need to pause every once in a while so I can cough. I'm a little sick right now. So awkward pauses, that's what's happening. All right, when you have a fraction within a fraction, I'm looking for denominators of like the fractions within. So I see a square root 15 here. I'm going to take the big fraction. You can see that I've highlighted those like numerator and denominator of the big fraction, and I'm multiplying by that denominator of square root 15. When that happens, this thing is distributed. All right, so it gets distributed to the 3, so 3 square root 15. That was distributed. When it gets distributed right here, it becomes 2 square root 15 over square root 15. So those cancel and you're just left with 2. So it's 3 square root 15 plus 2. On the bottom, 2 times square root 15 is just 2 square root 15. I'm not in the business here of rationalizing denominators. I'm not concerned about the denominator not being rationalized. So I'm not going to do it. Well, you know what? If you are curious, though, let's say you are curious about how you would simplify this. Why not? This is a video. I'm not wasting class time by doing this. Fast forward through this if you're not curious. You would just multiply by square root 15 on the top and bottom again. If you wanted to rationalize and get that denominator out of there, that radical in the denominator, that would then get distributed. Oop, and get distributed. Boom, boom. You would end up with 3 square root 15 times square root 15 is just 15 plus 2 square root 15 all over. These would combine to a 15, so it'd be 2 times 15. And then you would have 45 plus 2 square root 15 over 30. If you were curious. I'm going to undo all that now. You're welcome. And if you fast forward through all that, then that's awesome. I'm only doing that once for my own happiness there. All right, here. Multiply by, there's a 7 on top and bottom in the denominator. Multiply by 7. Distribute. I get 1 times 7 is 7. Then when it gets distributed here, the 7 will cancel and you're just left with a 5. Right? So the first distribution, That 7 right there is from that distribution, 1 times 7. Here, the 7's canceled. On the bottom, those 7's also cancel, and you have 2. This is 2 divided by 2, which simplifies to 1. Now's a good time to pause and try the rest of these on your own. I'm just going to continue forward, assuming that you've already paused and done that. All right, for this one, square root 10 on top and bottom. He gets distributed. You have 1 times the square root of 10, plus these guys will cancel when it comes to the second term. So plus 5 divided by square root 10 times square root 10 on the bottom is just 10. Boom. You know what? I'm leaving it. I'm leaving it. Beautiful. And for this last one here, 3, distribute, 3 on the bottom. Remember to do it on the top and the bottom. You have 8 minus 3 square root 5 all over 1 because these 3's would cancel. So that's just 8 minus 3 square root of 5. Just that quick review of complex fractions, it can help. All right, beautiful. All right, so the way these problems work, they look a lot similar to the way that the setup happened in the double angle identities. I wish I had left more room on this page. I intended to, but got tight on space. But anyway, these problems require a lot more keeping track of the pieces. So our first step on them, we were asked to find cosine, sine, and tangent of theta over 2, and we're given the fact that tangent of theta is -4 over 5, and that theta is between 90 degrees and 180 degrees. So we're going to use the information given to us here to find the quadrants of both theta and theta over 2. I'm going to go ahead and color code this. I'm going to have theta be in blue. I'm going to have any work I do on theta over 2 be in green. So starting with theta, angle theta, I'm going to mark this 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. I'm going to make a note here that I like to draw it out each time. I've been doing math for a very, very long time. I've been teaching for over a decade. I've been doing math for much longer than that. And I still on these, my brain wants to get turned around, and I don't know what it is about it. Like maybe it's the fact that when I'm reading angles, I'm so used to reading them counterclockwise that I start to read the angles going this way. And it's really easy to misplace the quadrant is what I'm trying to say. And I find it helps to draw the picture out with these things labeled and then say, okay, begins at 90, ends at 180. That's quadrant, that is quadrant 2. So theta is in quadrant 2. And we don't know how it got to quadrant 2 either. We just know that theta ends in quadrant 2. It terminates there. It could be a negative angle that goes around like a million times and then ends here. And that like halfway to like half of that angle might just be like something out here, right? Well, I guess we do know how it gets there. Just kidding. We know it gets there because it's between 9. This one says it doesn't just say quadrant 2. We do, oops, we actually do know how it gets there. So fine, I guess that spiel I was just about to go on, it makes no sense. Of course, it's between 100, it's between 90 and 180 degrees. So yes, we know exactly that it looks like that. It looks exactly like that. It couldn't have got there any other way because it says so right here. Not just quadrant 2, but quadrant 2 by those means. All right. Off of that tangent now. Theta's in quadrant 2 is the important part. Now we're going to look at theta over 2. There's choices that have to be made in these problems here. And the choice you're making is based on where is theta over 2? What quadrant is theta over 2 in? So coming down here, angle theta over 2. We start with the inequality, 90 degrees less than theta less than 180. This was given to us. And we say, well, I'm really interested about where theta over 2 is. So with an inequality, you can just divide all pieces of the inequality, even if it's compound like this, by 2. When you do that, 90 divided by 2 is 45 degrees, less than theta over 2, less than 90 degrees. So if I look at 0, 90, 180, 270, 360, 45 degrees is right in here, 90 degrees is right here. So we are looking at quadrant 1. Theta over 2 is in quadrant 1. Theta is in quadrant 2. Theta over 2 is in quadrant 1. Then use information from step 1 along with the fact that tangent of theta is equal to -4/5 to find sine of theta and cosine of theta. You only need sine of theta for this formula with tangent. For sine and cosine, you just need cosine. But we're going to find sine and cosine. So here's the information we know. We're talking about angle theta here. I'm going to make a note, angle theta. We know that tangent of theta is -4/5. We know that theta is in quadrant 2. We know all students take calculus. Oh, I didn't know that my color bar. Wait. Okay, just kidding. I thought something fun was happening there. Um, so sine is the one that's positive. I need to find sine and cosine of angle x. Sine of angle x will be positive. Cosine of angle x will be negative. And then I have this information that tangent is opposite 4 over adjacent 5. Hypotenuse. Sorry if you can hear my dog barking. He's getting a little excited. He thinks he heard someone at the door and he didn't. Archie, thank you. 4 squared, square root of 4 squared plus 5 squared. Archie, this dog, man. I hear you, bud. Square root of 41. So sine is opposite over adjacent. So that's going to be 4 over square root of 4, not opposite over adjacent, opposite over hypotenuse. 4 over square root 41. Cosine is adjacent. 5 over square root 41. Hey, Archie, come on. Hey, sorry, guys. He's a very grumpy dachshund right now. Growling. Stop it, dog. All right. So we're gonna do each of these formulas. I'm gonna zoom in and I should have left more space here. We don't have much space. Sine of theta divided by 2 is equal to plus or minus. Now, I am going to allow you to have a note sheet for your test, and maybe I shouldn't say that in the video just in case I decide against it in the future, though I don't foresee that. And this note sheet for your test is right here on this last page. I'm going to go ahead and give you just all of these things here. Anything you see on this page here is free for all. Again, keeping in mind that this formula here and this formula here really aren't half angle or double angle identities. They're just quotient identities in a fancy way. Anyway, what was I saying here? So you won't need to memorize these formulas because they are here on a formula sheet that you'll be given. However, I will say that memorizing them is not too bad because the sine and cosine ones are so similar. The way I remember it, I remember the general structure is 1 plus or minus, and then I know it's cosine theta divided by 2. And I think for sine, it's the opposite because it's not actually cosine. So it's the opposite one of it. And then for cosine, it ends up being the same thing. Cosine of theta over 2 ends up being the same thing, plus or minus the square root 1, but then plus because cosine is the same sign as the same trig. Cosine and cosine equals a plus. I don't know. That's how I memorize it. Like I said, you don't necessarily need to memorize it that way. But there you go. Cosine of theta, we have as negative 5 over square root 41. Let's see, 1 minus, did I say 5? Negative 5 over square root 41, negative 5 over square root 41, all divided by 2. Yeah. To choose the plus or minus, I'm going to come back up to here. Theta over 2 was in quadrant 1. All students take calculus. Quadrant 1, which is excellent. That means that this is going to be the plus on sine, the plus on cosine, and with tangent's formula, scroll out. Tangent's formula, you don't have to choose a sign. It does it for you. So that's nice. So sine of theta over 2 is equal to positive square root. And then the way that I would simplify this, like I talked about in the beginning of the video, I would multiply top and bottom by square root 41. I would get, and these are square roots within square roots, my friends. Square root of 41 plus, because a minus a negative is plus 5 over 2. And then don't forget the square root 41 in the denominator. So yes, square roots within square roots here. That's what we're looking at. They are messy, but they're not that bad to do. It really is just doing things you've done before. Boom. All right. Cosine. It will turn out to be the exact same thing. So this will be positive 1 plus negative 5 over square root 41, all divided by 2. And this becomes the square root of square root 41 minus 5 all over 2 square root of 41. So you can see the same exact thing, right? Same exact thing, just a minus difference. All right, and then finally, tangent of theta over 2. This is the formula I don't have memorized. 1 minus cosine. 1 minus cosine theta over sine theta. Cosine theta was negative 5 over square root 41. And sine of theta was positive 4 over square root 41. That simplification comes in handy here as well, right? This will be square root 41 plus 5, all divided by 4. That's tangent of theta over 2. Whew. I guess I didn't need to move those over so far if I was gonna make it so small, but let's see. There we go. Centered. All right. So there's one example. Let's go ahead and do it again. Twice. Let's go ahead and do it again twice. So suppose cotangent of theta is equal to negative 1/3. Theta is between pi over 2 and pi. Find the exact values of theta over 2, of cosine theta over 2, tangent theta over 2, sine theta over 2. Okie dokie. So we have, we'll do theta here, angle theta. we know is between pi over 2 and pi. So 0, pi over 2, pi, 3 pi over 2. This guy is 2 pi. Being between pi over 2 and pi puts us here in quadrant 2, right? And all students take calculus. We know that cotan of theta is equal to negative 1/3. We want to find cosine of theta over 2, tangent of theta over 2, and sine of theta over 2. So those formulas require us finding, for sine and cosine, those both require cosine of theta. Cosine of theta over 2, sine of theta over 2, those require cosine. And tangent requires cosine and sine. For, I don't know how to draw this. Cosine and sine for tangent. So I need cosine of theta and sine of theta. So let's see, this is Q2. We have that it's Q2. Cotan of theta is negative 1/3. I need cosine of theta and I need sine of theta. I know sine should be positive because we're in quadrant 2. Cosine should be negative. Theta is in quadrant over 2, I should say. All right, let's just use this. So TOA, tangent is opposite over adjacent, which means the soulmate cotangent would be adjacent. 1 over opposite 3. That makes the hypotenuse the square root of 1 squared plus 3 squared. So that's the hypotenuse is square root 10. Cosine is adjacent 1 over hypotenuse, square root 10. Sine is opposite 3 over hypotenuse, square root 10. And then we come over here, and we'll talk about angle theta over 2. We're going to start with this same inequality that we used over here. And it's always going to be the same. You're given an inequality or you're told which quadrant something's in, and then you have to make an inequality. You just need to divide everything by 2 to get theta over 2 in here. Quick math over here. Pi over 2 all divided by 2. You could take this and multiply the big fraction and the small fraction, the top and the bottom of the big fraction by 2. It would cancel here. You would get pi over 4. So if you divide pi over 2 in half, you get pi over 4. Same thing, like if you divide 1/2 in half, 1/2 divided by half is a 4. All right. So you have pi over 4 is less than theta over 2. Theta over 2 is less than pi over 2. This is actually the same exact setup that we had in this problem up here, because being in quadrant 2, this is just the equivalent statement in radians. So this is 0 pi over 2, pi, 3 pi over 2, 2 pi. Pi over 4 is right here. Pi over 2 is here. That means we are in quadrant 1. All students take calculus. So theta over 2 is in quadrant 1. And then we just use our formulas. So sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta divided by 2. Cosine of theta over 2 is the same exact formula, but instead of a minus, it's a plus. And tangent of theta over 2 is, again, the one I just don't have memorized, 1 minus cosine theta. I should be able to memorize that. 1 minus cosine theta over sine theta. And you don't have to choose a sign on this one. Because we're in quadrant 1, that means that both of these are going to be positive. Sine and cosine are both positive. Um, and then cosine of theta from right over here is, we'll just make you pink. Cosine of theta is negative 1 over square root 10. So this is 1 minus negative 1 over square root 10. Oops, no wonder that looked bigger. Negative 1 over square root 10, all divided by 2. Which will simplify to, let's see, square root 10 plus 1 all over 2 square root 10. Let's circle that in blue. This one is going to come out to be the same thing. It's just the only difference is going to be that plus right there is going to be a minus. That's just going to be how that math turns out. It'll still be square root 10, but it'll be minus 1 all over 2 root 10. You would plug it in the same exact way. And then finally, down here, we have 1 minus negative 1 over square root 10, all divided by, and then sine over here is positive 3 over root 10. Simplifying this, we get square root 10 plus 1, all divided by 3. Wham, bam, thank you, ma'am. All right, it's a little bit of work. It's not impossible though. Just, keep track of what you're doing. That's the real important thing. Keep track of what you're doing and which angles are which. All right, last one. This one is just finding cotan of alpha over 2. Let me make a note real quick. This letter you're seeing right here, this is a Greek letter alpha, so it looks like this typically, if you're writing it in your own handwriting, this is the lowercase alpha. You don't need to write this down. I don't know, I wrote down everything. Lowercase alpha, Greek letter. And then sometimes you're going to see beta. This is a lowercase beta. There are other Greek letters. Feel free to go look them up. Now is a great time to learn your Greek letters. You use them a lot in mathematics. If you're going to go on and take any physics classes, you'll be using a lot of Greek letters. So learn them now. Anyways, it's just a Greek letter like theta. Theta is a Greek letter as well. All right, cool. We're trying to find cotan of alpha over 2. We know the formula for tangent of alpha over 2 is 1 minus cosine alpha over sine alpha. That's literally this guy right here. Same formula, right? That means cotan is the flipsy-flu, right? So cotan of alpha over 2 is the flipsy-flu. So sine of alpha divided by 1 minus cosine alpha. Just this guy, but flipped. Either way, we need sine of alpha and cosine of alpha. Need sine of alpha and cosine of alpha. So for angle alpha, we know that pi is less than, oops, this should be an alpha right here. That should be an alpha. Change it. If I remember, I'll change it before you get to this worksheet. Alpha less than 3 pi over 2. I draw myself a little chart here. 0, pi over 2, pi, 3 pi over 2, 2 pi. Between pi and 3 pi over 2, that puts us here in quadrant 3. All students take calculus. So in quadrant 3, I know that that tangent is positive, everything else is negative. So sine of alpha will be negative. And cosine of alpha will also be negative. I know that cosecant of alpha is negative square root 7 over 1, really. So Katoa, a sine, the soulmate of cosecant, is opposite over hypotenuse. That means that cosecant is hypotenuse, square root 7, over opposite, 1. The adjacent side is going to be the square root of 7 squared minus 1 squared. So that's going to be square root 6. Sine is opposite, square root 6, over hypotenuse, square root 7. And then, and you could also, by the way, you could write this as negative square root of 6/7 if you really wanted. And then we have cosine, which is adjacent. Oops. My head was having trouble with this. I was like, something doesn't feel right here. And that's because sine opposite 1 over square root 7. 1 over square root 7. Adjacent is square root 6 over square root 7. I hope you've already started typing your angry email to me. Professor Cook, I cannot believe that you made a mistake. There was a mistake on this problem. All right, there it is. So we have sine is negative 1 over square root 7. Cosine is negative square root 6 over square root 7, or negative square root of 6/7. And then we go and we talk about angle theta, alpha over 2. Angle alpha over 2. Oops, I say alpha, I write theta. Alpha. I take this same inequality. I'm going to divide the entire thing by 2. 2, 2, 2. This becomes pi over 2 less than alpha over 2 less than 3 pi over 4. This is 0, pi over 2, pi, 3 pi over 2, 2 pi. So pi over 2 is right here, and I know 3 pi over 4 is right here, which means that we're sitting smack dab in the middle there of quadrant 2. So all students take calculus. I know that sine is positive and everything else will be negative. So when I go to set this up here, nope. Sine of theta over 2. I know that this is going to be, I'm going to be choosing I'll write the formula. Doesn't hurt to write the formula. And I keep on writing theta instead of alpha. Oops, not even did I tell you I was sick? My brain is trying to do something. It's trying. So this will be sine of alpha over 2. And then cosine of alpha over 2. Sine will be positive because we're in quadrant 2. Theta over 2, or alpha over 2 is in quadrant 2. So sine is positive and cosine is negative. So this will be a really nasty looking fraction. Square root of 1 minus, maybe I will write this as a square root 6 over square root 7 divided by 2. And what is this for sine of alpha over 2? So this sine of alpha over 2 is the square root of square root 7 minus square root 6, all divided by 2 square root 7. Whew. All right, this guy down here for cosine, it's going to be so identical to this, um, just slightly different. So there is a negative because he keeps his negative, right? So he's negative because alpha over 2 is in quadrant 2. And this is a plus sign. So this is a plus sign. Oop, mistakes everywhere. There was a negative. I missed that negative. So this actually has, oop, let me just come in here, add in a negative. Professor Cook, shouldn't you have this more polished? Well, listen, this is a non-professional production by a community college teacher. This is what I got for you. All right, this is negative. But this is a minus sign here, plus sign here, minus sign, plus sign. So this minus a negative turns to a plus here. This is a plus a negative. It's a minus. So these answers, the only difference here, right? This has a negative. This is cosine of alpha over 2. It's negative square root of square root 7 minus square root 6 over 2 square root 7. Tangent, last one, tangent of alpha over 2 is equal to 1 minus cosine alpha all over sine alpha. 1 minus, okay, good. 1 minus negative square root 6 over square root 7 all over 1 over square root 7, negative 1 over square root 7, negative 1 over square root 7, right here from sine. This will turn out to be square root 7 plus square root 6 all over negative 1, which is negative square root 7 minus square root 6. That is what tangent of alpha over 2 is. Dun, 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 dun. All right. Whew. Okay. So those are how those problems work. Just keep your information separated from one another. If you have questions, let me know. I hope this video helps a bit, and I will see you in the next video where we talk about composition of trig functions with double angle identities. All right, bye.